Have you ever thought of having medicinal mushrooms? Or are you scared of them? Or maybe you have been consuming medicinal mushrooms and have found them to be helpful, but you'd like to know more. Maybe you have questions about how effective they are. Are you asking, where is the scientific evidence? If so, you have come to the right place. I'm Govind Nair and welcome to the Mushroom Rice podcast, where we'll be answering such questions while exploring the fascinating world of medicinal mushrooms. What I have seen is that when you are out in the market to buy medicinal mushrooms, what you often find is a lack of useful information and an abundance of useless information. This creates nothing but confusion for the consumer, who will then have to do their own research to find a good product or, unfortunately, end up buying bad quality mushrooms. The aim of this podcast then is to make that process easy for the consumer by presenting science-backed, objective information on medicinal mushrooms. And today, we are going to talk about turkey tail mushrooms, which are not only very popular, but as we shall see, strongly backed up by decades of research as well. The way we will go about this is, first, we'll be covering a bit of background on turkey tails, after which we'll be looking at what the research says. And based on that data, we can then take a look at the commercially available turkey tails. There's a lot of information to unpack, which I'm very excited to share with you. So, let's jump right in. Turkey tails are these semicircular, fan-shaped mushrooms, which grow on dead wood in forests throughout the world. I'm sure most of you would have seen turkey tails or other similar mushrooms. What distinguishes turkey tails are the dark and light, colorful rings which adorn its surface and which give turkey tails their scientific name, Trametes versicolor. However, it was also called Coriolis versicolor, and in most of the research using turkey tails, this is the name that has been used. Versicolor means of many colors, and it also looks like the tail feathers of a wild turkey. The earliest written record of turkey tails being used as a medicine is from a hand-dynasty text on medicinal herbs written in 200 BC. So at least from that time onwards, it has been used in Chinese traditional medicine, where it continues to be used to this day, mostly for treating lung and liver diseases. Before we get into the weeds of the research, we need to know what is it in turkey tails that give them medicinal properties. And the answer is mostly polysaccharides, particularly PSK, which is polysaccharide K or crestin, and PSP, polysaccharide peptide. These were isolated by Japanese and Chinese researchers in the 70s and 80s. The story goes that in 1965, a Japanese engineer reported cancer remission because of consuming tea made from turkey tail mushrooms. This led to further investigations, which led to the discovery of the polysaccharides PSK and PSP. Polysaccharides are nothing but long chains made up of monomeric sugar molecules like glucose. For example, sucrose, that is normal sugar, is made of two monomers, glucose and fructose, and starch can have thousands of glucose molecules. PSK and PSP are basically polymers made of chains of D-glucose, but other sugar molecules like mannose and galactose are also present, and there could also be side chains connected to the main chain. As such, these are heavy molecules with a high molecular weight. To give you a comparison, white sugar has a molecular weight of 342 daltons, but for PSK, it's around 100,000 daltons. I say around 100,000 because PSK is not a homogeneous molecule. It's actually a mixture of molecules of different sizes. In both PSK and PSP, the polysaccharides are bound to proteins, and these proteins can be 25 to 38% of the mass of PSK. The polysaccharides are called beta-glucans, which simply put are polysaccharides with a specific main chain and side chain structure. And it is the beta-glucans which give turkey tails most of their medicinal qualities. Now, beta-glucans are not unique to turkey tails. All fungi have them, and mushrooms are fungi. Not only that, beta-glucans are found in bacteria and cereals as well. However, they are not all the same when it comes to physical and chemical properties. What that means is beta-glucans from another organism might not have the same effect inside the human body as beta-glucans from turkey tails. Polysaccharides in turkey tails are a part of its cell wall, and other than polysaccharides, turkey tails also are known to have secondary metabolites, which are small molecular weight compounds, many of which are also pharmacologically active. Therefore, we want to get these useful compounds out of the mushrooms, and the way to do this is by breaking up the cells. This process is called extraction, and the most common extraction method for turkey tails is hot water extraction, where powdered turkey tails are steeped in hot water for 2 to 3 hours, achieving a 5 to 7% extraction. This is followed by evaporation to concentrate the extract, leading to a higher percentage of beta-glucans. These extracted beta-glucans are said to be bioavailable. That is, they are in a form ready to be absorbed and used by the body. The advantage of this method is that it is cheap, and beta-glucans have a better solubility in water compared to other frequently used solvents like ethanol. But there are other extraction methods like enzyme extraction and ultrasonication, which, as the name suggests, use either enzymes or ultrasound to break up the cells. These methods are more efficient compared to hot water extraction, but they are also more expensive, and the amount of material processed by these methods is usually smaller. Also, different extraction methods facilitate the concentration of one particular type of compound at the expense of others. For example, ethanol extraction is better at extraction of alcohol-soluble compounds like terpenes and phenols, which have antioxidant properties. But this is a major area of innovation, and a majority of patents related to turkey tails are being issued for novel extraction methods. Basically, companies and researchers are trying to come up with more efficient methods to extract turkey tail bioactives. Coming to the medical side of things, when it comes to research on medicinal uses of mushrooms or any other drug in general, there are 3 experimental methodologies that are important to understand. These are in vitro experiments, in vivo experiments, and human clinical trials. In vitro literally means in glass. So we are talking about experiments conducted in a test tube, or as is more likely nowadays, in a microplate, which is a plate of about this size with many tiny test tubes. In vitro experiments reveal biochemical properties like what molecules the drug reacts with or which genes it interacts with. In vivo experiments are conducted inside a living organism like mouse, rat, or hamster. And these also reveal biochemical properties, but at a higher level, like how the immune system or other organs respond to the drug. Clinical trials are the final stage where patients are given the drug in a clinical setting and monitored by medical doctors. The biggest difference at this stage is that the focus is more on clinical parameters like disease-free survival, the patient's quality of life, and adverse effects than the mechanism of action of the drug. For turkey tails and cancer, all 3 types of experiments have already been conducted, including phase 1, 2, and 3 clinical trials. Now, we don't have the time to get into all the details, but here is a short version. In vitro experiments with turkey tails on cancer cells have found that many cancer-related genes are downregulated, which means that less of a gene's products are produced. You see, a gene itself does nothing. It's just coded information sitting in the DNA. When that information is processed by the cell, proteins are produced, and it is the protein which does something. Downregulation means less of the protein is produced, and upregulation is the opposite, where more of the protein is produced. In vivo experiments have shown that turkey tail extracts can stop tumor growth, kill tumor cells, and stop their spread. And they achieve this by A, modulating the immune response to attack the tumor cells, and B, by slowing down DNA synthesis, which means the capability of tumor cells to divide, grow, and spread is affected. Turkey tails have been used in Japan since 1977 and in China since 1984 as an adjunct therapy. That is, it has been used along with conventional chemo and radiotherapy. Since then, there have been many clinical trials using both PSK and PSP, but mainly PSK. The specific cancers targeted were gastric, rectal, lung, breast cancer, and leukemia. Most of these studies have found that using PSK with chemo was better than using chemo alone and led to better patient outcomes like improved survival and less side effects from the chemotherapy. Also, most of these were long-term studies involving hundreds of patients, and these patients were monitored over 3, 5, or 10-year periods. We are talking about over 40 clinical trials involving over 18,000 patients. Interestingly, in his 2011 TED Talk, Paul Stamets, who is perhaps the most famous mycologist in the world, talked about how taking turkey tail extracts cured his mother's cancer. We just saw that one of the ways that turkey tail extracts perform their action is through immunomodulation, which means changing the nature of the immune response. Many studies have been conducted on the immunomodulatory capabilities of turkey tails, but most of these experiments have been in vivo experiments using mice. These experiments have shown that turkey tail polysaccharides induce B cell activation and upregulation of cytokine genes for certain interleukins and TNF-alpha. These molecules play important roles in our immune system, and their activation and upregulation are correlated with better disease-free survival. Also, we know that beta-glucans are directly responsible for immunomodulation, but the mechanism by which this happens is not completely understood. The antioxidant properties of turkey tails have also been well studied. In-vitro studies have shown it to be an excellent antioxidant. In vivo, it enhances the activity of naturally occurring antioxidant enzymes like superoxide dismutase. These antioxidant capabilities have been found to depend on the amount of glucuronic acid in the side chains of the polysaccharides and also on their molecular weight. The higher the molecular weight, the better its antioxidant capability. More and more papers are coming out every year demonstrating the action of turkey tails against many different infectious agents like bacteria and viruses. In fact, currently there are 2 clinical trials underway in the US testing the use of turkey tails in anti-COVID therapy. They also seem to have prebiotic effects. In one study, healthy volunteers randomly treated with PSP showed clear and consistent changes in their microbiome. Further, turkey tails have been reported to have anti-diabetic activity. Here, however, except for cancer, immunomodulation, and antioxidation, more studies are definitely needed before we can conclusively say that turkey tail extracts are useful in these other diseases. Also, no studies have reported any adverse side effects from consuming turkey tails. Talking about the dosage, most studies used a dosage of 3 grams per day of PSK. I have also seen a dosage of 100 milligrams per kilogram of body weight, which equals 1 gram for every 10 kilograms of body weight. Till now, we have talked about the medicinal uses. However, research is also being done on the agricultural and industrial applications of turkey tails. For examples, they could be used to control aflatoxins, which are carcinogenic compounds produced by certain fungi which infect crops and seeds. They could also be used to break down lignocellulose, which is present in wood and crop stalks, which can then be used in animal feeds or for biofuel production. In one interesting piece of research that I saw, scientists created nanofibers out of turkey tail chitosan. Chitosan is another polysaccharide. These nanofibers were then tested for wound healing capabilities, which found a 93% growth inhibition of Staphylococcus aureus and a wound healing rate of 95% in animal experiments. Overall, we can say that although we have a good knowledge of how useful turkey tails are in combating various diseases, we still need to know a lot more, especially about its mechanism of action and also the structure of its polysaccharides. Now, since we have looked at the science, we are in a good position to take a trip to the market and critically analyze commercially available turkey tails. Based on what we know, the first thing you want to know is how the beta-glucans have been extracted. As I had mentioned before, only the extracts are bioactive. Extracts also happen to be 10 times more potent compared to powdered mushrooms. The second data point you should look for is the beta-glucan content. Most of the immunomodulatory effects, which also contribute to its anti-cancer activity, are due to beta-glucans. Hence, the percentage of beta-glucans should be mentioned. Other type of numbers, for example, ratios like 8:10 or 1:2 are not good enough because they cannot be interpreted in any way to tell you the absolute percentage of beta-glucans. The third thing you should look for is what you don't want in your mushroom, like microbes, pesticides, heavy metals, fillers, additives. That one should be obvious. I know most sellers do not provide such data, and many don't perform any quality control or safety tests. The simple fact is such tests are easily done through a third-party consumer lab, and it is not expensive. So if a seller is not providing a consumer lab report, I would call that a red flag. And ideally, each batch of mushrooms produced should have a separate report. There is also a belief that mycelium, which is kind of like the root system of a mushroom, is not useful. Actually, research has shown that not only the mycelium, but also the fermented substrate, which is what you grow the mushroom on, usually it is something like brown rice, are bioactive. More importantly, nearly all clinical trials have used mycelium extract, but these were grown in big fermenters and used a liquid medium. So mycelium itself is not bad, just check for impurities and the beta-glucan content. Turkey tail extracts are also available in the form of tinctures. These are usually alcohol extracted, but multiple extraction steps, which will include a hot water extraction step, are not uncommon. Now, we know that phenolic compounds are more soluble in alcohol. Hence, tinctures have a high amount of these compounds. If a hot water extraction is also performed, polysaccharides could also be present. However, one has to keep two facts in mind. One, polysaccharides do not dissolve in ethanol. And two, a majority of tincture content will be either alcohol or water, and the compounds that we are after would make up only a small fraction of the total. Also, it has been found that even hot water extracts contain many phenolic compounds. Plus, no tincture bottles mention the percentage of beta-glucans on them. From all this, what I conclude is only a small portion of the total mushroom bioactives are actually present in a tincture. And other than some convenience maybe, it is not clear what the advantage of a tincture is compared to an extract. As far as the dosage is concerned, most studies used at least a few grams of extract per patient per day, No data exists on a good disease-free dose, but it is generally agreed that at least a gram of mushroom extract needs to be consumed to see potential health benefits. To summarize the important points, the positive effects of turkey tails in cancer therapy is unquestionable, but there is still much that we don't know. However, research is going on at a breakneck pace with the discovery of new bioactive compounds, better extraction methods, and the treatment of more diseases. Also, remember that turkey tails have been approved for use as an adjunct to conventional therapy, not as a cure in and of themselves. And when buying mushrooms, always ask for a third-party consumer lab report. Finally, please consult a medical professional before consuming medicinal mushrooms. And with that, my dear mushroom lovers, we have come to the end of this talk. In the future, we will be exploring other medicinal mushrooms, and we'll also be bringing on researchers to share their discoveries with us. So, stay tuned. Until then, stay healthy and stay wise.